Awesome. Well, thanks everyone for attending today. This is our second session in our winter Kubernetes workshops. Today we're going to be building a cluster. So we'll be going through a short deck and then we'll do some live demoing. Once I run through the demo, it should take less than 10 minutes. We'll spend the rest of the session in breakout rooms and we'll help each other all get our clusters running. Before diving into the content, I just want to go over the code of conduct. Women Who Code is an inclusive community dedicated to providing an empowering experience for everyone who participates in or supports our community, regardless of gender, gender identity and expression, sexual orientation, ability, physical appearance, body size, race, ethnicity, age, religion, socioeconomic status, caste, creed, political affiliation, or preferred programming languages. Our events are intended to inspire women to excel in technology careers, and anyone who is there for this purpose is welcome. We do not tolerate harassment of members in any form. Our code of conduct applies to all Women Code events, and online communities. And you can read the full version and access our instant report form at womenwhocode.com/code of conduct. Very cool. A little bit about me. I'm an engineering manager focused on Kubernetes infrastructure. I've been doing that for the last 2.5 years and have been in previous IC and technical team lead roles in the preceding 8 or 9 years. I've been a director for Women Who Code DC since mid-2020, so coming up on 4 years. And I've been a Cloud and DevOps lead since late 2019. Virtualization is sort of my specialty, and I love to talk about it. Most sessions that I run are around virtual systems and distributed computers. Today is going to be pretty hands-on. I know our previous session was a little wordy, and so today we're going to put those words into practice. I'm still working on getting the recording going on, and that should probably be up here in the next day or two, I'm hoping. Working with Global to get that to a reality here. And this one should hopefully be up much shorter. So we're going to be using three key tools today. They're going to be Docker, kubectl, and Minikube. Once we have those installed, we're going to run through the basic commands. We're going to get our expected result, which is going to be a nice little dashboard and a little hello world app. And then from there, we're going to jump into those breakout rooms. And then we'll spend the last 15-20 minutes at a QA and free to ask any questions about these technologies. Cool. And so I'll do a quick dive through all the apps. Docker, which is going to be a key tool. On your laptops, you'll install this Docker desktop. If you're interacting with servers, it's just Docker, Docker-CTL. And it allows us to manage containers, and you'll see it in work environments as the most common way to build containers on desktops. There are a number of ways to work with containers in modern environments, but Docker really kicked off the containerization movement around 2012, 2013. But so if we're talking about the containerization movements, what are containers? Containers are little replicas of environments. They're described in a Docker file usually, and that captures desired or current state of a system, and it enables the replication of that system as many times as needed. This, in large environments, helps to reduce the complexity of using applications and their dependencies. It makes it very reliable to deploy systems, and it's a key part of how systems work, how applications work inside of Kubernetes. And today we're going to be using Docker as sort of the foundational component, which will allow Minikube and kubectl to run a cluster on our laptop. Cool. Any questions about Docker before I move on to kubectl or Minikube? Cool. And then kubectl. So kubectl, you might hear as kubectl, control is an application that handles authentication and allows us to process commands to Kubernetes servers from a local client. So the key part of Kubernetes for access and processing commands, both how your application and how we as system administrators use, is the Kubernetes API. And kubectl is sort of the key way to perform those interactions. There's other application-specific ways, like Python has a Kubernetes API, Go has a Kubernetes API SDK that can interact with it in a bit more programmatic or system native way, language native way. But for day-to-day interacting with it in a quick and consistent manner, we're going to use kubectl. And then once we have the cluster built with Minikube, we'll be able to log into that cluster and run our application and view the system state using kubectl. And so if we're talking about the cluster, that's going to rely on Minikube. So Minikube is this wonderful little application that creates an entire cluster, the whole API and all the networking and security stack, and it runs it in as small of an environment as possible. Kubernetes, like by default, is a system designed to work at a very large scale. And so one of the problems people had when they were first starting to use it 5, 6, 7 years ago was by default, you need at least 2, if not 3 systems to get a Kubernetes cluster working. Because a lot of the logic around how the cluster exists is held in this concept in a process called etcd around decision making, and to have not concurrency, but a trust within that system, it requires at least 2 out of 3 nodes to make that decision. And so what Minikube and some other similar projects like K8s or Kind do is run modifications to etcd to allow it to not need that level of concurrency and can run, and then it's further streamlined to be able to run on very small systems. So it's great for quickly building out, testing and validating your assumptions, understanding Kubernetes as a whole, and the barrier to entry is free and will work on a system you own today instead of needing to build out onto larger cloud systems or larger on-prem systems or more experimental things like little Raspberry Pi clusters. There's lots of people who build little Raspberry Pi clusters to run home labs. And so we'll pull this all together today. Once we get Minikube live, we'll get a little dashboard application. We're then going to review that dashboard and I'll show basically all the key components, do a little chat on both of those, or all of those. There's like 30 parts of a Kubernetes cluster. And then we'll launch our first application. We'll view how it looks inside the dashboard as well as how it would look at kubectl. And then from there, we can delete the cluster to clean it up, or we can leave it so you can continue to experiment after the session. Cool. Any questions before I dive into the demo? Everyone who joined a little later will be working through here. And I'm going to share my screen again here. We'll have a terminal. Just want to confirm we can see it all. Awesome. Okay. So I've previously gotten Docker installed on this system. I can verify its state is here. Got Docker version, Docker status, probably a little behind on this computer. Sorry, it's Minikube status. Sorry, that would show you a live sort of task manager view. Also go ahead and verify that I have kubectl installed.
Hey, Camille, is it possible to make the font just a little bit bigger for the terminal?
Absolutely. Thank you for calling that out. Cool. Does that look better?
Yes, thank you.
For anyone who didn't catch that, what I just did was Docker version and then kubectl minus version. Cool. So we got 1.28.3 and we got 23.0.1 of kubectl. And then I'll do the same for Minikube version. This is just validating I have these installed. Cool. And we got v1.32.0. So I've gotten those baselines installed. We need to make sure Docker is running, else Minikube will fail, and then later kubectl will fail. And what I'm going to do is I'm going to start Minikube. I'm going to grab the version string here just to make sure we get a consistent version. Kubernetes is a very fast-moving system. They release new minor versions every 3 to 4 months, and then they release patch releases as often as they need to. And so we're going to grab major version 1, minor version 29, and patch version 1. That's 1.29.1. I'll copy that into the chat. And don't worry about needing to have any of this right along, as we'll also jump into these again during the breakout session. I'll go ahead and hit enter now. And this usually takes about a minute or two to get running. While it's running, you can see basically it's pulling up and downloading. Basically verified that it could find that version. It's checking that Docker is running. We're at 23.0.1 of Docker, so we're good on this minimum version. And now it's starting the control plane. The control plane node is going to be the core node that runs and configures what are considered worker nodes where you can run your applications. You can see here it provisions it with 2 virtual CPUs and 4 gigabytes of memory to start. Later, if we needed that to be larger, we can reconfigure that in the live system. And so here it's checking the SHA hashes, then it's downloading kubectl, kubeadm, and kubelet. Internal to the Kubernetes API, they also use kubectl. So it's a lot of the system that used to interact with the system is used to, on a local system is also used to build the system as a whole. It's a very neat kind of way to handle it so that there's less interfaces as a whole. The Kubernetes system is very both homogeneous and heterogeneous. It's an open specification, so anyone can design to and against that system. They can modify it as they need, but it's very homogeneous in that it has some pretty clear design principles and they follow those. The system is already provisioned. This ran a little faster on today than it did when I was testing out this weekend, but we now have a cluster as Minikube. And the default namespace is set up. Cool. And we can validate that. We're going to run a quick command in our kubectl. We're going to make sure we're grabbing the Minikube context, and we're going to just describe the system as it is. You can see there are no applications installed. Cool. From here, we're going to do a quick setup of the dashboard. We're going to install the metric server. This will give us some neat visualizations and make sure we're grabbing all the core components. It does add a little bit of overhead, so it's not installed. It's not added by default, but I find it to be well worth it. And then now that that's done, we're going to actually run the Minikube dashboard. There's other ways to install this dashboard, but as Minikube has done a very nice job of integrating it and launching it, found it was better to stick with the path. Cool. I'm going to switch my screen share real quick. And it automatically opened up my default browser. And it gave me the cluster dashboard. And so from here, we can look at the cluster. And this is a visualization of a number of the role bindings that were created there. And we can actually go ahead and see. Oh, geez. There we go. I think my Minikube might have captured some metadata from a previous experiment. Yeah, it still got some data from a previous experiment of how she's saying I didn't purge this one fully. Basically, we can see from here how it would describe the nodes if this was on a larger system. You would see multiple nodes. The Kubernetes dashboard can be used on production systems, but it doesn't have a full RBAC suite as you might see on some paid products like Rancher or EKS. We can see the Docker runtime that it's using. It's using 24.0.7. That's going to be a little different than our Docker version because the Docker version is correlative to the desktop and not necessarily the Docker CLI. Docker CLI is usually a few versions ahead. You can see the kubelet and kubeproxy version. Kubeproxy allows access from external systems to internal. The cluster translates the network. And then the kubelet version is part of like how the API is defined. And it's currently set where a system has a maximum capacity of 110. Right now, those are pods. So those are the maximum amount of pods. Each pod share a network that it can generate with its CNI, and that's a current limitation by default in all Kubernetes clusters. The maximums for nodes right now in a single cluster using the default settings are 5,000, and then maximum pod capacity per node is 110. And you can see like active CPU, memory, and then pods. They have a bunch of pods, but they don't have any pods. Not sure if it's getting a little confused there. That's sort of the high level of the dashboard when you're tackling the concept of a cluster. And once we get our hello world, you'll be able to see it as a deployment and then as a pod. Deployments can deploy multiple pods, replica sets, deploy a fixed set of a fixed count of pods, and then stateful sets can deploy either a fixed or a variable set. Both stateful sets and replica sets usually have the capability to handle stateful workloads and handle PVC claims, whereas deployments you shouldn't have PVC claims in a flat deployment. We can also see over here on services, the Kubernetes service itself. This is sort of the cluster control plane and how it's configured. Has the API server. It's using cluster IP. There's a number of types. You'll see cluster IP, load balancer, And that basically is saying where it's accessible. Like this is the IP that I currently have for inside my internal network. And I could access it either via 10.96.0.1 or 1.27.0.0.1 or localhost. Just as those are the sort of generic references that you can access systems on. And it has 0, which is going to bind it to all as a port available, as well as 443, which is HTTPS. All of our kubectl commands by default are going to be sent over 443 or HTTPS. And that ensures that all commands set to the server are encrypted from the time you hit enter. We don't have any ingress classes, but those can be used to set priorities. Say you have an application that needs to boot up faster than any other app. Say if there was a cluster downtime or node downtime, it would recover first. It's useful anytime you need to try and stagger or control the order of operations inside your cluster. And then you'll also have services, which we'll see a little bit here once we get the Hello World app going. Services allow you to attach to network endpoints in ingresses. They're sort of the translation layer between the ingress where you access it or you enter the cluster, and then the actual pod. So the pod specifies that it works with this service, and then that service connects to an ingress so that the ingresses have a little bit of obfuscation and room to be configured to handle more than one service. It gives you a lot more long-term flexibility when you're designing your applications. Cool. Verifying we can see the terminal.
Yep.
Okay. Okay, and from here, we've got the dashboard running. We were able to access that insight. And now we're going to go ahead and we're going to launch a Hello World application or a Hello Node application. In this specific case, we're going to use kubectl again. We're going to create a deployment. We're going to name that deployment Hello Node. The image spec is specifying where to pull the image from. This could be your local computer if you're running Docker, or a OCI compatible open container interface registry. It's saying it should run against and then open the endpoint AGN host, and then it's telling it to open it against the port 8080. 8080 tends to be sort of default Java or JavaScript endpoint for accessing systems. Yes. I'm going to go ahead and execute that now. Yeah, you would do like localhost and then the port and then the path. It pulls pretty quickly. I may have this application already local, but we can actually see it here. So we can verify that the Hello Node app is available. It's using an application deploy strategy of a rolling update. It's not currently available, and then we can see the pod actually is saying it's available now. We can also verify it here. So we can see it's live, and you can get a little more detail on the containers. You can also see that via the command line kubectl to describe namespace. Making sure to use the context as I have multiple systems installed. We can do describe pods instead of namespace. Oh, sorry, that was in default. There we go. -n or -n is the command line trigger to tell kubectl to use a namespace. And so we can see all that same information we saw on the dashboard here. The dashboard does a pretty great job of breaking these sections out. But it basically tells you when it was created. You can see the start time. It can tell you any labels that we've set. We can add a bunch of labels or annotations. You'll often see annotations and labels used for things like describing which environment or which team created it. Lots of ways to provide metadata or segmentation is then further based on labels. You might run into things like Open Policy Agent or Kubernetes, which is used in production settings to help validate that workloads are permissible. As you get into security concerns, that might be something we cover in another workshop. But right now, we can see all this stuff about the data, but we can't actually access this. And so what we'll do now is go ahead and perform an expose command, exposing it to, in this case, not the internet, but to our local system. We're going to specify again, it's a deployment type. We're going to reference that hello node. We're going to use a load balancer, which is going to be different from that cluster IP, and we're going to use a port 8080. Load balancers are really important inside of Kubernetes. It's going to use what's called the ingress-nginx load balancer, which is an open source project as part of the open source but semi-paid Nginx after it was bought by F5. They open sourced that and gave it to the CNCF, which is the foundation which manages Kubernetes and other applications inside the cloud native community. Or once again, going to set it on port 8080. If you know you have something running on port 8080 locally all the time, you could set it to a different port. And then this is going to set it up for the cluster, but Minikube has a little bit of an interesting network stack. And so we're actually going to run a command that lets Minikube tell us that it's accessible. So we're going to do Minikube service hello node, and then we're just going to do an ampersand in the background. That's going to allow us to continue to access the application without it hanging our terminal session. And so likewise, it should open up a new URL. Perfect. Cool. And this little application just describes the time. One of the neat things about like containers is you can sort of describe their state. I'm always a little bad about breaking some of these things. But what I can do is do, actually do this locally. Cool. That's an Minikube image. There we go. The nice thing about Docker and images, we downloaded an image file, but it's actually split up into all these little layers. These layers are just single line text files, so they're always viewable. It makes it really easy to, in the long term, analyze like security scenarios. Like we could actually go through and patch this, and this would be a great topic for another session. But you can see the entire system state that hello node application runs. We can see, it downloads some applications. This allows it to pull the system time. It's running a copy of QEMU, which is another virtualization technology. This is it exposing the ports that we end up using. It's setting an entry point. That's where the application is going to begin, and there it's going to pull a command, which is pause, telling it to not do anything else. But that's sort of the makeup and layout of the Docker containers. So I see some questions. Did you have to manually set these layers or did Docker create those for you? Someone else manually or automatically created the Docker image. So I won't go into this demo, but like what you could do is like you could pull usually what's called like a base image, like a Linux operating system usually. So what I would do is do like a Docker pull Ubuntu 18, and Docker Hub has a bunch of stats. Let's see, yep. So Ubuntu is going to be pretty simple. Hosting the OS and usually like a minimal version of the OS with no additional layers. Like it's just pretty basic. And then what I would do is run a bunch of commands, and then exit out of the image, but capture the new state. And then I can push that as my own customized version of Ubuntu. If that makes sense. That's sort of how you interact with Docker files. They end up being really iterative. You can also copy a Docker file. Let me pull up the Docker file. Hello world. So Docker has their own hello world, and they used, I don't know if they still have it. They used to have a really nice interactive one where you would recreate all of this. Actually, this is not necessarily the one, but basically what we're seeing visualized in the Docker desktop app exists as a Docker file somewhere. And it's just running through the commands and making sure they all get run successfully, so it builds successfully. It's a nice way where the system is always sort of constantly checking the state and validating as it goes. That way there's less likely to be issues when you go to repeat it. I also see if you're, yep, local path. Cool. I think we're caught up on questions. So that is actually sort of it for the demo. There's one last thing I wanted to do was just show the service list so you can see everything Minikube exposed. Cool. Apologies. There's some leftovers on this computer from a demo I was a participant in, not a demo I was running. But we can see in the default there's hello node and the Kubernetes server. And then over here, you're going to see the metric server that we installed as well as DNS. DNS is really important for the core networking using the internet standard domain name system. And then Kubernetes dashboard, you're going to see the metric scraper in the Kubernetes dashboard, which relates back over here.